ChatGPT is the hype right now, and obviously I had to do the high-level system design of ChatGPT. So when I found out that one of the participants of my HLD course who is a data scientist, is very experienced, I jumped at the opportunity. So without wasting any time, let's get started. Let me introduce you to Love.
Hi, it's a pleasure to be here. I was one of the students with Keerti in our course for high-level system design. A bit about myself. I'm a data scientist working in a company, in a Dubai-based company called Aramex, which is one of the largest players for logistics in the Middle East. I joined the company as a data scientist, and later I became more responsible for the designing the machine learning systems and the deployment and the data engineering part of it. So the reason I joined Keerti's course is this was not my original background, so I wanted to learn the basics of system design in detail and know my concepts well, and this course has been hugely helpful for me.
Great. I am sure you will do great in the discussion. So let's get started. Before we go ahead, I would just like to say that I have had so many participants of my courses on the channel right now. And this speaks for itself that the courses are a huge success. And if you're interested in making your experience easier, better, faster, and if you can afford it, you should be checking out KeertiPurswaniCourses.com. The next course, the live LLD 5-week course, is starting on the 19th September. Please don't miss it, because I get a lot of messages saying that I missed the deadline. Now what to do? It is a live course. Try to join it live. If not, and if you want to watch the recordings, that is also possible. The HLD recordings are also available. All the details are mentioned on the site. There are separate FAQ sections for LLD, HLD. If interested, do check it out before the last date. Without wasting any more time, let's continue. So Love, since you are a data scientist and you have so much experience, plus you recently took the HLD course, so it would be interesting for you to design ChatGPT today. It would be something very different. I am sure we both will get to learn a lot, and the audience will get to learn a lot. So why don't you design ChatGPT today?
Sure, my pleasure. So let's start a bit about with the who will be end users.
Okay.
So the end users will be just people like you and me. So everyday users who ask questions, asking questions to solve their problems. Now let's jump straight into what kind of functional requirements we want from ChatGPT. So we can divide it into, say, basic requirements and extended requirements. So what are the basic requirements needed for ChatGPT? First requirement would be like to create a chat conversation. Another would be send message in the conversation and receive reply from the AI. And another requirement could be once you send, once you received an answer from the AI, maybe you can do a thumbs up, thumbs down to see if these answers are useful, to give them feedback. And then you can also delete the chat conversation. And if you want to maybe switch to another conversation, you can view the messages of the other conversation. So that's the basic requirements. We can also look at some extended requirements. For example, you can switch between the less powerful GPT 3.5 and GPT 4 model. There are some plugins which are connected to, say, Wolfram Alpha or Expedia. So these are third-party plugins. And there's also the feature of sharing the chat conversation with other people. So suppose you've had a useful, insightful chat and you want to share it with some other people. This could be one of the features. And there are many more which we can discuss, but for the limitation of time, we'll move on. Sure. Okay, so let's move on to non-functional requirements. So I think the most important thing is it should be highly available. The chats, you should always be able to click on the chat and see the messages. Maybe the messages are out of order, but it should be highly available. It should be a highly available system. The latency, since it's a very big transformer model, latency will not. Sometimes won't be that fast, but it should be, say, a few seconds, so that the user experience is not that bad. But it can be. It's a very big model, so sometimes latency can be. It won't be in the millisecond range. Sometimes it'll be in the seconds range, and then it should be highly scalable. So if there's a surge of users, we should be able to handle it. And say security wise, we should have secure login, as well as rate limiting and protection from DDoS, so that the machine learning model is not overwhelmed by these attacks. And yeah, that's that, and it should be obviously resilient and fault tolerant as usual. So that's some of the non-functional requirements. Now we can move to capacity of estimation.
Sure. Yeah.
So I did what I saw, there was the monthly number of visits was around 1.4 billion. So per month visits. So we can estimate approximately, say, 50 million DAU, daily active users, just as an estimate. And we can assume that each user asks, on an average, some will ask more, some will ask less, some are like power users. So maybe they'll ask 5 questions and get 5 answers from the AI. So we can assume each Q&A pair to be, I don't know, Q&A pair to be around 200 bytes.
200
so
bytes, okay.
Does that make sense?
Yeah, that's right.
Okay. So so for a day we can estimate 200 bytes into 50 million per day. So that's around, am I missing something? Oh yeah, into 5 questions. So 5 questions. So that is around 50 GB per day. Yeah. And if I take it down to 5 years, I can take this 50 GB into approximately 2000 days. So this should be around 100 terabytes of storage.
Okay. So
And
this
if you
much
want
storage
to-
for 5 years. And this is just, so in storage you're considering only the question and answer right now, right?
Yeah, I mean, we could also consider, say, the titles and other things. Yeah.
Okay. Okay.
Yeah, but I assume that's quite small.
Yeah. Okay.
Then we take the bandwidth. So if it's 50 GB per day, that's 50 into 10 raised to 3 into 10 raised to 6. So we can assume like 1 million per day is, say, 12 per second. So it will be 50 into 12 into 10 raised to 3. So this will be around 600 kilobytes per second. Does that make sense?
Yeah.
Okay, great. So let's move on to the sequence of events, how the app will function. So first thing the user can do is create a chat he can send a message which will, and he will end up receiving an AI reply. Maybe he can rate the reply with thumbs up or thumbs down, and he can choose to delete the chat or switch to another chat. So that's how the flow of the application will be. Does this make sense?
Yeah.
Okay, great.
Looks good.
Awesome. So let's now move to the meat of things and see the high-level design. So we'll have millions of users obviously using this service. So I'll just create some boxes. And so there'll be so many requests to this application. So we'll probably need a load balancer to handle the load and distribute it along different servers. So we have users, we have a load balancer, and then we can go to like something like a chat service. So obviously all of them are connected to a chat service. So when we create a chat, it will so we can store the chat. We can store the created chat in a database. We can opt for a NoSQL database because these are conversations, so the data is more semi-structured.
Okay.
Also, using something like MongoDB would be useful because it scales horizontally. So I think chats can really overflow and go into GBs and TBs. So something which is highly scalable.
Could you tell me
So-
exactly what all things are you storing in this DB? Like what?
Yeah,
like
sure,
if,
sure.
Say MongoDB. So how would the document look like or something?
Sure. So we can maybe save a mapping of the user ID and the chat ID. So this will be like love, and it will map to say the UUIDs of the chats which I've created. And we can also save the chat ID mapped to the messages. So maybe 1, 2, 3, 4 will be mapped to. So it will. So the whole chat history will come within this. So we can have a list of JSON object, and we can have the role. So this will be like it will be to differentiate whether the message is from a user or is from the AI. So if I say hi, and then I have another message coming back from the AI, which is saying, how can I help you? So this is how the data model will be.
So the chat messages is what you're storing in say MongoDB. The user chat mapping that you talked about, that also you're storing in MongoDB, or that you're storing separately?
Yeah, I'm storing in MongoDB because that's also like a list, kind of unstructured.
But user to chat, is it unstructured? Like for one user, there will be like a list of chats or number of chat IDs only, right? That's just a mapping that you're storing.
Yeah, I mean, we can store in like a relational database also if you want.
Okay. But since this is you're going to need highly scalable and it is read heavy, so probably you could use MongoDB as well. But probably different like DB collections for user chat as well as for chat messages, correct?
Yeah, probably different documents, or different DBs.
Okay. Yeah.
Yeah.
Different collections. Yeah, got it.
Yeah, different collections. Sorry. I think we can also have like a cache in front of it, like a Redis or something, because so what happens is like whenever you go back to a conversation, it has to get loaded again. So this DB will be probably called many times. So instead of like whenever you click a conversation, the messages have to be loaded. So if it can pick up from Redis, it will be better. And also one more thing is like when you continue a conversation in a chat, it usually send the ChatGPT model the whole like not necessarily the whole conversation, but at least the last 3,000 tokens, so that it has context of all the previous conversation. So we need the so basically we need the chat history a lot. So it's probably good to have a caching layer over here.
Makes sense. Yeah.
Yeah. So so that's chat creation. That's pretty simple. Chat deletion is also pretty simple. Viewing chat also we can retrieve here. The interesting part is now we'll go on to sending a message to the AI. So how does that work is it receives a message from the chat service, and first it goes to it's sent to a moderation API. So it flags for all the messages which are, say, harmful or harassment or say sexual. So it will flag all these messages as inappropriate, and then the chat service will just send back some standard message that they cannot answer this or something like that.
Okay.
Yeah, but if this moderation API is passed, we go to say the ChatGPT service. So behind the service is a large language model, which everyone's heard about nowadays. ChatGPT model. So this is probably hosted on a cluster of GPUs, and it's probably optimized for very fast inferences.
Could you talk about this model a bit, like for the beginners over here?
Yeah, sure, I can talk about it. So GPT stands for Generative Pre-trained Transformers. So it's a kind of a deep learning model. Transformers is one of the most important papers, one of the most revolutionary papers, which was published by Google in 2017. It was a new architecture, which at the heart of the architecture, there was a concept called self-attention. So self-attention, what basically it means is when you have a sentence, say, my name is love. So if you're looking at name, so which are the words most relevant to name? So love is very relevant. So the self-attention mechanism is able to identify these relationships within the sentence. So this was a very revolutionary model, and GPT is like a subclass of transformers. And the original transformer has an encoder and decoder, but the GPT makes use of the decoder part, and it's supposed to be very fast. I can go even more detail if you want. Should I?
No, it's fine. Yeah, go.
Okay, great. So the ChatGPT model, it gives back tokens. It gives back one token at a time. So a token, so how these models work is they take like certain tokens inside. So basically each sentence can be divided into tokens, which are like approximately words, but it can be like part of words. So these models take multiple tokens inside, and they spit out one token at a time. So you take the one token out and you feed that back in, and this is how these models work. So that's why when you go to ChatGPT, like you see like it's coming in a stream of tokens. The answer is coming in a stream of tokens. So what you'll do is maybe you'll in the ChatGPT service, it may package the history over here, and it'll go to the ChatGPT model and hit the model, which is hosted on a cluster of GPUs, and this will give back one token at a time. to the chat servers.
Is
and
it
back
similar
user.
to the streaming of a video?
Yeah, so I think I did. I think it is event text event. Yeah, it uses text events. Yeah, so it's kind of similar. Yeah, I think even the accept header has text event. Yeah. Yeah. So so that's how this works. Am I missing something?
You could go back and look at your requirements if you want to do that.
Yeah. This is very interesting. We can talk about thumbs up, thumbs down. So this has some interesting machine learning concepts also here. So suppose you get an answer, the user gets an answer, and he or she is not satisfied with the answer. They can there's an option in ChatGPT called like thumbs up, thumbs down. So maybe I'll cover something like thumbs up means it's a good answer. So that's kind of an affirmation that is a good answer. But thumbs down means it's like a bad answer. So sometimes like when you press a thumbs down button, so on the what you will see is on the left hand side there's the old answer, and on the right hand side there's a new answer. So you must be thinking like, how does ChatGPT generate another answer? Because it should always make the same answer. But if you try it on ChatGPT, if you try typing the same question again, sometimes it comes up with a different answer. So that if you go into detail, is like there's many approaches of generating the next token. One is like the greedy approach. So if you take the token with the highest probability, that is the greedy approach. But there are other approaches too, which introduce some randomness. So there's a top K approach. So maybe we randomly select from the top 5 tokens which have the highest probability. And there are other approaches too, like top P. Maybe the top you consider only the next token only among the top 15% of probabilities. So that's how ChatGPT can generate like different answers when you ask the same question. So what the feedback service? What happens is we generate another answer, and then so this can be handled by the feedback service. So basically, you select which answer is better, the old answer or the new answer. So maybe you say, okay, the new answer is better. So the feedback service can say that, okay, the new answer is the actual true answer. So maybe I can store this in like a retraining database.
Can you talk about the retraining database a bit? Like what kind of database?
Yeah, so I think it'll be mostly a question and answer database. So you have a question and you have an answer. So you have a better answer now. So this database can be used to retrain the ChatGPT model, because now you know that the user has given you feedback that this answer is better. So you can retrain the model with the retraining database.
Okay, but okay, so when are you storing the info into this? What all info are you storing? Can you like discuss a bit in detail?
Yeah, sure. So I mean, when you do a thumbs down, you select which is the better answer. So maybe like a SQL database is enough for this. You can store the question, you can store the answer, and maybe other metadata like user ID, time, etc.
Okay.
Yeah. So this can I mean maybe directly maybe this can directly go to the retraining pipeline and retrain the model, or maybe it will go undergo some analysis and filtering, and then it can be used for retraining the ChatGPT model. So that's how they use the feedback from the users to retrain the model. If you want, I can go a little detail into how the model is trained.
That would be helpful. Yeah.
Okay. So it's actually very interesting. So there are many stages of training for training the GPT 3.5 model. The first is, so it's called large language model. Do you know why this is called a language model?
No, I'm like a developer. I have no idea.
No problem. So you must have heard like I think OpenAI has crawled over several websites, like most of the internet, a lot of the internet. So it has crawled maybe Wikipedia, Reddit, GitHub, etc., and like reliable websites, maybe Quora also. So how a large language model is trained? Basically, you pass the job of this model is to statistically guess what is the next token. So you pass like a couple of tokens inside, and it has to guess which is the next token. So your training set is basically, so it's a family. It's something called unsupervised learning or self-supervised learning. There's like two words for this. So or self-supervised. So to make it simple, like supervised learning, you actually need to have a data set where you have like a question and an answer, and someone has to prepare it. But in self-supervised learning, basically the next token is the answer. So I like to run the model should be able to guess fast or quickly or something like that. So the answer in the data set, the next word is the answer in the data set. So that's how you train it. So you give a number of tokens, and you train it on a loss function so that it can guess the next token. Does that make sense?
Yeah.
Okay. Then another phase of training is, so now at this stage, this model has like understood the grammar and semantics of English language and whatever other language you've trained it on, but it's not actually aligned. You must have heard this word alignment a lot online, like the models need to be aligned to humans, etc. So it's still not aligned to human needs. For example, you might ask, what is the capital of France? Okay. Yeah.
You can just okay. Yeah.
What is the capital of France? So what I said is this large language model is trained on a large corpus of internet data, but it's still not aligned to human how a human would expect to use it. So for example, if you ask what is the capital of France, what would you expect the ChatGPT to answer you?
Paris.
Yeah, true. But maybe this kind of model, which is still like unrefined, it will say what is the capital of Germany. So something gibberish which you don't expect. So this might be
Okay.
It might have seen some textbook where there's a lot of questions on capital of several questions.
Okay.
So to get a model aligned, it needs to be like three things. It should be harmless, it should be honest, and it should be helpful. So that's how you know that the model is aligned to human needs. So what you do in the second step is this is something very like manual. Okay, so to align it better to human needs, there is a process called supervised fine-tuning. So this is a very manual process where OpenAI, they've hired a lot of contractors, and like many of them are like subject matter experts. So what they're doing is like they've created a question answer set, and maybe like someone is expert in finance. So what is options trading? So they'll answer a very detailed and nice answer. So they'll create a very large set of training data set, and they'll further train this model. So this will be like the fine-tuned model. But they've only so now the model is much better. It's more like a chat model which can deal with humans. But then there's another step that they do. they train something called a rewards model. So after the model is fine-tuned, like I said, the model can give you multiple answers, right? Based on this paradigm called top K or top P. So we sent a number of prompts into this fine-tuned model, and we get a number of answers. And once again, humans are told to rate which answer is better than which. So they have to rate which answer is the best. So this rewards model, based on the input question, it will give you like a scalar reward function. So it'll give you like a number, which like this is a good answer, this is a bad answer. So now based on this rewards function, I won't go too much detail in this, but this is kind of, they say it's the magic sauce, but I don't know. So there's do something called reinforcement learning. So to explain simply, like how you train a dog, for example. If a dog does something good, you feed him a treat. If it doesn't do something bad, maybe you scold it. So it's like, so this rewards model is rewarding, is helping us tune this fine-tuned model even further through the rewards model. And we at the same time we have to make sure this fine-tuned model is not changing too much from the basic model. So that's another theory called, you have something called KL divergence loss. So anyway, not going to detail. So using reinforcement learning, we further tune the model, and then we end up with the final model, which is hopefully honest, harmless, and helpful.
Interesting. A lot of stuff that I don't know, but sounds interesting.
Yep.
Can you go back to the requirements? Let's just go through the workflow once, and let's see if we have covered everything.
Yeah.
Okay, so if we have to view the okay, can you also write down the APIs for like creating the chat, deleting, or viewing the messages, or can you write down the APIs?
Yeah, I'll do it. So maybe to create the chat, it's should I write the URL can be something like /chat/gpt/v1/chat, and the payload can be maybe the title, or sometimes you don't even need the title, it's self-generated. And the response will be like a unique ID, UUID. And let's see the delete. So the URL can be /chat/gpt/v1/chat/the UUID. There's no payload, so the response can be empty. So it's just a delete request. And then to view, it will be a get request. So again, you can probably use the same URL, /chatgpt/v1/chat/UUID. And then the thumbs up, thumbs down. It can be a post request. The URL can be /chatgpt/v1/chat/UUID. Maybe you can go to message and the UUID of the message. What I forgot is the send message service. Send message your API. So that will be another post request. The URL can be /chat/gpt/v1/chat/uuid/message, and the payload can be it will be like the role, maybe it's like the user. It will probably be the user only, yeah. And then the message, maybe it's a JSON, yeah. And then the response will be a UUID. Does that make sense?
In the get one, the get chat one, the chat is going to be huge. Say you have been using the same chat to get a lot of messages. So how would you deal with that?
You mean the chat history?
Yes. So in the same chat, there are a lot of messages. Like you're not going to get all the 200, 500 messages together, right? So how are you going to deal with that?
That's a good question. Maybe we can like truncate to say last 50, something like that.
Yeah, and if we want to see the further messages, the history, we could use pagination. So we can say that this is the offset, I want messages from here to here. So we could use pagination over there in get.
Okay, makes sense, yeah.
Also, so one is getting the messages within a chat, and one is when you open the ChatGPT, there would be like all the titles and all of that, right? So there would be another getter for that also. So
Yeah,
get all the
okay.
chats. So
Yeah,
can
get
you
all the
mention
chats.
that as well?
Sure, yeah, thanks. So like get chats, URL can be /chat/gpt/v1/chat, and
Cool.
yeah, the payload can be a list of chats. Yeah. You can also like get these chats, and like some of them are like last week, some of them are last year, so you can maybe like map it to that also.
Yeah, makes sense. Great. This looks good. Is there anything about the design that you would like to cover?
I think that's pretty much it. If you have any questions, let me know.
Give me 1 second to think. Should you be so about monitoring and all? Would you like to mention anything? Like, especially everything that we do is actually added to another model, right? That like every single question that is asked, so that question is also sent for like further training, right? So one is retrained that you talked about when there's a thumbs down, but every single question is actually also going to the model, right?
What do you mean going to the model? The
Like,
model can only
the further questions that I ask would be answered on the basis of what I have asked previously, or the answers that I have preferred previously, right?
yeah. So that how that happens is like ChatGPT, it sends 3,000 tokens of your history to the model. The model doesn't have any, like the model is stateless essentially. It cannot remember anything.
Okay.
You just give it you just input something and it spits out something. So how you manage that, and I've done this in LangChain also. So you just take a chat history of say 5 to 10 messages, or in case of OpenAI it's like 3,000 tokens, and that's how it's been able to make sense of the context.
Okay. Another thing, so the like ChatGPT is used globally, right? So you have to take care of global distribution. Could you talk a bit about that?
Global distribution. So maybe you could host the models, maybe a few copies of the model, depending on which regions are like hotspot. usage places, like probably India there's a lot of usage, in the US there's a lot of usage. So maybe you can host these models behind CDNs so that you have low latencies in those areas.
Okay, got it. This looks good. Thank you so much. Should we get to the feedback part now?
Sure, yeah.
So love, this was amazing. I'm sure like a lot of people got to learn a lot. ChatGPT sounds very scary because it's a new buzz thing, and you are a data scientist, so you are familiar with it, but I am sure you also helped a lot of software developers understand it is fine, like you can still deal with the high level system design of ChatGPT without actually knowing all the details. So you really helped in that sense. But could you talk about your experience and how many HLD interviews or how many HLD discussions have you faced so far, and anything like that you would like to share?
So I'll come to why I joined the HLD course. I'll come from my context. So what happened is a couple of years ago. So my basic role in my company was as a data scientist. I was hired as a data scientist, and we had a vendor who took care of all the software side, the machine learning engineering, data engineering. So suddenly these people, they were a big cost center and they were fired, and suddenly we had to like scramble and learn everything about AWS and a lot of things. So the last year has been a very big learning experience for me, and so I understood everything at the AWS level, but I just wanted to understand everything from first principles, from the concept. So that's why I think this course was very useful. I think you have this ability to make the class very vibrant and engaging, and I think that's full credit to you. And the kind of knowledge, the vast breadth of knowledge I got was, I think it'll be very useful going on for me for designing very scalable machine learning systems, because the company where I work at, it's called 𝐼𝐸. It's a Dubai-based company. We are a logistic company, so we deliver over 100 million packages a year. So we are talking about very huge scale. So if I make mistakes in the system design, it's going to be like very problematic for me. So these concepts are something which will really help me in my performing my job better.
Wow, that's a lot of pressure. But then you have so much of experience. Like there were also college students in the course. So did you feel it very slow or boring, or did you feel the discussions were too easy for you at any point?
No, I think it was just the perfect amount of difficulty for me. I think I had some context, but there was a lot of things I didn't know about, and this really helped me fill the gaps in my knowledge, and I think it was really hugely helpful. Yeah.
Great. Thank you so much for coming and doing this. And this video was very well structured. Like again, you started from functional requirements, non-functional requirements, capacity estimation. You did it properly, like you knew your calculations, you used the the calculations that we use usually, and then you drew the diagram. You were so confident all the time. Just a couple of things. Try to mention the, like, since you had time, you could have mentioned the APIs yourself. You could have mentioned extra things like logging, monitoring. When you have time, try to show off your knowledge as much as possible in the interview, because that's what we are trying to do basically.
And I have like actual experience with logging, monitoring. It can be very headache. Like when your application is failing, it can be like you have to do something fast. Yeah.
Yes. So those are the things that people usually don't mention in the interview because you don't have time. But you had the time, so you could have used it and you could have mentioned a few more things. I know you knew all that and it is not really important to mention also. But it is like, in terms of interview, this is a tip for the audience as well. If you have the time, try to keep mentioning as much as possible so that your interviewer thinks like, okay, the guy is not going to stop talking, and then goes like, all right. Yeah, this is just little things over here and there that I keep mentioning.
Yeah, makes sense. I think I'll take that feedback to heart. Yeah.
Great. But you did a commendable job. I got to learn a lot, and I'm sure audience also got to learn a lot. It takes a lot of guts to come and do an interview in front of the camera. Being able to speak so fluently, so properly, it shows your experience speaks for itself. And it's a really an experience, and I am truly grateful to be able to have you as part of the community. So thank you so much for coming and doing this. Really means a lot.
My pleasure, and thank you for adding so much value. Yeah.